Alright, Chapter 3, Polynomial Functions. So Section 3.1 is characteristics of polynomial functions. This is going to look a lot like grade 9 actually to start. So what is a polynomial? What is an example? Well, probably if I was to ask you, the most common example I might get is something like 3x squared plus 2x plus 5. So some kind of quadratic, something that makes a parabola. And that's a trinomial. Or maybe you would have given me like 3x plus 2. Well, that's a binomial. There's two terms. And then finally, we might even have someone giving me like 4x squared. So only a single term. So a monomial. Now, if there's more than 3 terms, it's just a polynomial. And all of these are polynomials. We just don't have a specific name for anything with more than 3 terms. So then what is some vocabulary you've learned in the past? Well, our 3, 2, this 3 here, this 4, anything in front of these variables, those are our coefficients. And then our degree of the polynomial is based on the highest exponent. So this is a degree 2, this is a degree 1. Now we don't write the 1 normally, but it is a degree 1, and this would also be a degree 2. And the final piece of vocabulary is the constant. So that's going to be your term that doesn't have a variable in it. It's possible it doesn't have a constant. So here there is no constant. So this constant is 5, this constant is 2. So here we have a slide just showing all the general information of what makes a polynomial versus what isn't. Some of this we've already gone over. So the degree is the highest exponent. Our constant term, there is no variable here. So note there again, there's no variable there. Something that is different though is we have a leading coefficient. So what is the coefficient next to the highest, or the variable with the highest exponent? And then, well, what is an actual definition of a polynomial, or what makes it so it's not? So n has to be a whole number. What that means is my exponent cannot be like x to the power of 5/3. Now we've dealt with that before. From using flower power, we know that's x to the power of 5 and then cube root. But that is not technically a polynomial. It also means whole number, you can't have a negative. So x to the power of -2, if you have that in there, not a polynomial, because that's actually 1 over x squared, which breaks a different rule, which is number 4 here. Polynomials don't have variables in the denominator. They need to be whole numbers, so no square roots either. So here we would see that our variable is in the denominator, so that one's not going to be a polynomial. X is a variable, so that could be y, it could be z. The coefficients a to n, a to 0, well, those are real numbers. Now that's a pretty open. It just means we can't have the letter I in there, or we can't have like the square root of -3, because it's not possible to square root -3. And then finally, polynomials have smooth continuous graphs. This means no sharp corners. So our degree 2 is a parabola. So it's smooth, it's continuous everywhere. Our cubic function will look something like that. Again, smooth. If we just have a degree 1, so a linear equation, then again, smooth, continuous. But then what type of graph would have sharp corners? Well, there's two types of situations. One is going to be an absolute value. So that absolute value might look something like that, and right there is our sharp corner. The other possible situation is a piecewise function. So maybe 2x plus 1 is only for the parts where x is greater than or equal to 1. And then maybe we use like 5x when x is less than 1. Now this might create a sharp curve, or this might make it so it's not continuous. Either of those conditions are met, it's not a polynomial. So our first example, for each polynomial function, state the leading coefficient, degree, and constant term. So our first one, 3x minus 2, leading coefficient is right here, 3. Now we don't write the degree 1, but it is there. And then our constant isn't just 2, it's -2. Okay, our next one, what is our leading coefficient? So we don't write 1s if that's the coefficient, so it would be 1. Our degree is right here, it's the largest exponent, so 3. And our constant term is -1. This one's a little bit tricky because we just have a constant here. So our constant is 5. It's a degree 0. Now technically, and this is the leading coefficient one, is, maybe we could argue that it's 5. Maybe there is no leading coefficient. I'm just going to put NA. The reason we could have that argument is we could actually write 5x to the power of 0, because x to the power of 0 just becomes 1. So it's just 5. This is saying the same thing. So technically, is that a coefficient? I guess so. I just prefer to put NA, and we just say that's the constant. Finally, this is the generalization. So our largest degree is n, and with that then, our coefficient is a subscript n, a sub n. Our constant term is way over here, a to the power of 0. I know that because there is no x variable there. Again, maybe, yeah, there is an x to the power of 0, but that's actually 1. We don't need that. That's just a to the power